Today I'm going to talk about a subject very dear to my heart, which is the subject of mathematics education. So most of my talks have been about mathematics in technology, but today we're going to look at mathematics education, and in part we'll look at the way that technology plays a role in that. The title of my talk is How Will We Teach Maths in the Future? And this has a double meaning. It means how, as in how will we teach maths in the future, and also how, as in how on earth will we teach maths in the future. And I hope the double meaning will become clear as we go through the talk. And I better warn you, I will be throwing some questions at you to think about during the lecture to keep your brains active, as it were. So I'll start with a little bit of a history lesson concerning me, and show you a picture. And this is a picture of one of my primary schools. I went to two primary schools, one in London, which was excellent, and then we moved, and I won't say to where because I want to keep this anonymous, to a school which was less than excellent. And this school had a very progressive headmistress, and the progressive headmistress decided that mathematics was not a creative subject, and therefore she would not teach it at her school. So basically she banned teaching maths. I don't know how it was possible, it was the 60s. And so, of course, I love maths and I really wanted to do maths, and I had to rebel against my headmistress in order to do maths. So that was the 60s. Things have moved on since then, fortunately, and moved on a long way. And in 2011, I was honoured to be part of a committee which was chaired by no less a lady than Carol Vorderman, and we produced a thing called the Vorderman Report, and that was called World-Class Education for All Our Young People, and that was a report for government, and that made lots of recommendations, and that really got me to think very much about the issues of mathematics education, and that was in 2011. And what I want to do is tell you a little bit about what that report concluded and tell you how things have gone on a long way since that and some of the great educational initiatives that are going on now, and then how we're looking forward into the future about how maths will be taught and also how we will teach it in the sense of how on earth we will teach it. So this was essentially what the start and conclusion of the Vorderman Report said. It said that mathematics is an incredibly important subject because it is the language of the sciences and many, many other things, and it's how we communicate when you do technology, and it's also a very, very important part of our lives. And mathematics itself is a great subject which fosters logical and creative thinking. So this was our great motivation for mathematics and why it should be taught well. But at the same time, there was this warning that this great language and that language of numbers is one which many people cannot speak, and that is a great disadvantage not only to them, but to the country and our future as a whole. And that's why we felt it was so important that maths education was done well, and done not just now, but of course well into the future. So that was the basic conclusion of the Vorderman Report, and I want us to take you through some of our thinking behind this, and then, as I said, move on to see where we're going and where things are now heading. So there are many reasons why it's good to have a good maths education. And one which greatly appeals to most children at school, I believe, is that it's very useful. Okay, it's very straightforward to convince a child that something is good if you can tell them they'll get a job at the end. It's not the only reason, but it's not a bad reason. So the CBI wrote a report about the value of numeracy, and indeed of mathematics in general, and came to the conclusion that 70% of all jobs require some level of numeracy. 70%. That's a very large number when you think that a large proportion of the country isn't particularly numerate. More recently, the Deloitte company was asked by the government. The government funds a lot of research in mathematics and related subjects, and they wanted to know if their research money was being used wisely. So they asked the Deloitte company to do a survey into the value of mathematics research. And that's the sort of stuff I do at university, so the actual probing the frontiers of knowledge in maths. And they came to the conclusion that it contributes 208 billion to the UK economy. 208 billion per year to the UK economy, and 10% of all jobs. So 10% of jobs rely on the outputs of mathematics research. And one thing about this is that mathematics research is actually very cheap. To do mathematics, basically, you just need to pay people. You don't need huge labs. You don't need a great deal of equipment. So this is a massively good return on investment. And then on the BBC website, so it must be true, they did an article. They tend to do this every year, looking at what degrees are worth a good value for money. And they came to the conclusion a degree in maths in 2018 will give a higher boost to your earnings than almost any other subject. So medicine and law edge ahead, as possibly does economics, but mathematics is very high. And in fact, they said the single group of students that had the best earning potential in the country were female students doing maths at Oxford. What do we conclude from that? It's good to do maths at Oxford if you're female. So there we are. Maths is a useful subject. But I don't think that's the only reason to teach it. It's a good reason to teach it, but it's not the only reason. I would claim that utility isn't everything. My favourite book in the entire world is Winnie the Pooh. Okay? I don't know how many of you would agree with me. It's a wonderful book. But I do not read Winnie the Pooh just so that I can learn how to escape from a rabbit hole. Okay? So there's Winnie the Pooh stuck in a rabbit hole. I think far too often mathematics or many subjects are, people say, well, you should only teach things which are useful. No, there's many other reasons to teach it. You certainly wouldn't not teach areas of literature because they're not useful. I love Winnie the Pooh, whether it's useful or not. So if we look at a subject like a mathematical statement like 2 + 2 = 4, that's a fantastically useful subject thing. It's a very useful to do that calculation. We can do many things with it. But sometimes people in the press or wherever say, well, maths is a terribly uncreative subject because 2 + 2 = 4, you just do it, it's very mechanical. And that misses the whole point that this statement on its own may not be important, but the concept of addition, the concept of abstractness, is an incredibly creative statement in its own right. And mathematical statements are very, very creative, and it's the ideas behind mathematics and the way it all fits together which are a very, very important reason for teaching it. And if you don't know this formula, in my opinion, that's the greatest formula in the whole of mathematics. So a second reason for teaching mathematics is the ideas behind it, and the way that it helps us to understand the world. And Celia Hoyles, in her address as IMA president, that's the Institute for Mathematics Applications, summed it up beautifully, saying maths is best thought of as a collection of strongly connected ideas and logical thinking and of understanding the world. So if we want to teach young people how to think logically, how to think creatively, how to understand the world, maths is a very, very good way to do it. And it's the ideas behind maths and the modes of thinking behind maths which have led to so many great things. Things which I've covered in the lectures that I've given and I will give in this series, but things like Google, the internet, mobile phones, and much, much more besides. These come from the ideas that form the body of mathematics. As a way of just confirming that, I'm very pleased to say that at the present, mathematics is the most popular A-level. I couldn't find the most recent statistics, but this is 2015, 2016. These are the various A-level subjects, and there's mathematics at the top. Okay, just over 80,000 students were taking it then. Second is English, and third, interestingly enough, is psychology. Anyway, whatever you want to think about that. But mathematics is the leading A-level. And the students that are studying that, well, some will go on to do mathematics, but the majority that are studying maths A-level are doing it because the ideas are so relevant to many other subjects. These ideas that they learn, subjects like engineering, medicine, even music and the social sciences. So we should teach maths partly because it's useful, but also because of the ideas behind it and the way they train us in logical thinking. Another reason we should teach maths is because it is fun. It's a wonderful subject to have fun with and to be creative with. And I think sometimes these aspects of it are sometimes missed in the way that is taught. Here's an example of fun maths. If you buy the newspapers, you can do puzzles. A lot of the puzzles in newspapers now are based on maths. This is Gridler, where you have to find a picture by working out how many black and white squares there are in the picture. And I just enjoy doing this a lot, but the ideas behind this are very closely linked with a branch of maths called inverse problems, which is used to do things like find oil. I shall boast slightly here, I'm very proud to say that I'm currently the chair of a wonderful organisation called the United Kingdom Maths Trust, or the UKMT for short. And the United Kingdom Maths Trust produces puzzles and challenges for schools, for young people to do. And these are very, very popular. The trust works with something like 80% of the schools in the country. Over 800,000 young people per year do the problems for the UKMT. And they do them because they stimulate logical thinking and because they're fun. And because they have to think creatively to solve the sort of challenge that they pose. So young people really enjoy doing these things, and you can very much bring out the fun and creative aspect of maths by doing it. So here's a nice quote from a medal winner that by doing these puzzles, they expanded their horizons. So just to keep your brains active for the remainder of this lecture, I will throw up a little puzzle for you. This is one of the puzzles that we put on the Intermediate Maths Challenge. It's evening, and Meg, who's 1 metre tall, casts a 3 metre long shadow. She stands on her brother's shoulders, which are 1.5 metres above the ground. How long is the shadow which she and her brother will cast? Okay, so that's something for you to think about. As I say, the best way to learn maths is to do maths. Do some maths in your head. I will give you the answer at the end of the lecture and pose you another problem for you to think about on the way home. So there are 3 good reasons to do maths. It's useful, it's a great training in logical thinking and the way ideas work, and it's fun and creative. However, one of the conclusions of the Vorderman Report and of many other people that have looked into education, both in the UK and beyond, is that there are significant problems with the way that it's been taught, both in the past and also in the present. And I want to kind of look at a number of different ways in which I see that there are problems with the way it is taught. I should say that there is great maths teaching out there. There are great maths teachers, but that doesn't mean that it's uniformly great. There are definitely problems. So one problem is that I think there are false perceptions of what mathematics is and how it should be taught. False perceptions which are exemplified by saying maths is just a mechanical subject, 2 + 2 = 4. So here are some of the image problems that we have for maths, which are certainly how it's portrayed by the media and sadly by some teachers. So it's considered to be hard, it's considered to be irrelevant, it's considered to be uncreative, and it's supposed to be only for geniuses. Okay. I would also say, but I didn't want to put it in writing, that it's only done by geeks and people with no social skills. But that's unfair. Okay, so this kind of image problem has the problem that it puts people off and can lead to what is often called maths anxiety. So I want to kind of unpick some of these thoughts, that it's hard, irrelevant, uncreative, and only for geniuses, in a minute. But here's an example of exactly where this image came across. About 10 years or so ago, maybe a little bit longer, there was a speech at the National Union of Teachers by, I believe, a maths teacher who said that they should essentially ban the teaching of quadratic equations at schools. I suppose that's an advance from my primary school where the whole of maths were banned. Now it's just the quadratic equation. There were various reasons that they said it should be banned. The primary reason was that it was completely useless and no one ever need know what it was. And the second was that the quadratic equation, there you can see, is very frightening and was upsetting the students. So this, was put across. It got into the media. The media had a sort of feeding frenzy. Every journalist was saying, yes, I agree, I hated maths at school. Particularly, well, I won't mention them by name, but some quite leading journalists were putting this across. One said, at last someone has said the truth. They should ban it all. And this led to a debate in the House of Commons. It's the only time I think they've had a debate on an equation. I believe they're having a debate tonight on some other subject. The debate, in this case, went on the side of the quadratic equation. They showed some sense. Let's see what happens tonight. Anyway, so it's wonderful that it led to debate. I actually wrote an article based on the whole affair called 101 Uses of a Quadratic Equation. So if you read that article, you can actually find 101 uses of a quadratic equation. So do I agree with these? Do I think these are fair? Is this a fair thing about the quadratic equation? Well, of course I don't. I think it's wrong. So, as I say, maths is portrayed in the media as being irrelevant, but I've already shown you it's very useful for jobs. And in fact, the quadratic equation is incredibly useful. You need it to find things like areas. You need it to work out stopping distances for cars. You need it to be able to solve differential equations. There's all sorts of reasons why the quadratic equation is a very useful thing. They claim that maths is uncreative. Well, again, I hope I've shown you already that maths is highly creative. But the quadratic equation, crazily, is a good example of how creative it can be, because the solution of the quadratic equation took people many hundreds of years, and people all around the world aimed at solving it. The Babylonians put some work in, the Greeks put some work in, and the final solution came from people from India. So it demonstrates itself the creativity that goes into solving a mathematical problem. Maths may be hard. It is hard. I puzzle a lot over mathematics. I have sleepless nights trying to solve mathematical problems. But many other things are hard as well. For example, sport is hard. To take a free kick is hard. To play well at football is hard. To play music well is hard. I tried very, very hard to play the piano and didn't succeed. Doesn't mean I don't like music, but these are hard things, and they don't have the same negative connotations about them that maths does. If we look at maths anxiety, I do agree that maths anxiety exists, but I don't think it's any different from any other anxiety. I think people are anxious about many things. I am personally very, very anxious about sport. I was terrible at sport at school. I'm not very good at other things, like I'm hopeless at speaking foreign languages, and I got quite anxious at school about that. But I don't think that that's a reason to say that these are negative things. People get anxious about what clothes they wear. Only in maths, I find, does the sort of maths anxiety get celebrated in the media almost as a positive. And that worries me a great deal. And also, the fact that people get anxious about what clothes they wear doesn't mean that the business of wearing clothes gets criticised. I think maths seems to unfairly get treated in this regard. Okay. Another problem that we've had, at least until recently, fortunately changing very much for the better, is in the UK, people have been giving up maths very early. Here is a table that we had in the Vorderman Report showing the different amounts of maths studied by different countries after the age of 16. So if you see, Japan studies, everyone studies some maths, and a lot of people study advanced maths. In France, most people study some maths, and a medium amount of people study advanced maths. But if you go down to England, few people study any maths past 16, and very, very few numbers study advanced maths. And the UK really, must be wrong, it's not the UK, England, Ireland and Wales, but not Scotland, really stand out or stood out because we were not teaching maths to most people past 16. There was a policy in many schools of students being put in for maths GCSE at 15 and then doing no mathematics after that. A very, very negative thing. So Scotland is better than the rest of the UK, and Japan and Korea are way, way ahead of us in this regard. What's the effect of this? Well, there are a number of effects. One consequence is that many people that have gone through the English system, including the vast majority of our politicians, the vast majority of our civil servants, and the vast majority of the media, have had very little contact with mathematics after the age of 16. And even changing things now is not going to affect that historical thing. There are some MPs that have mathematical training, but very few. I'm pleased to say the House of Lords is much better in that regard. There's some very, very good mathematicians and scientists in the House of Lords. But the worry about this is that we are in the danger then of our politicians and our policymakers missing out on the technological revolution that maths is bringing. All the changes that are happening, the big data, the algorithms, the deep learning, they're in danger of missing out. Very interesting contrast with Singapore. So the most recent Singapore president, Tony Yam, has a PhD in maths. And a recent Prime Minister of Singapore not only went to Cambridge and did maths, but got the top maths degree in his year. They're really, really different. Singapore is really a hothouse of technology and driving things forward. Possibly an even more serious consequence of people giving up maths at the age of 16 is that primary school teachers, a lot of them have had very little serious training in mathematics. In a recent survey, that's more recent than Vorderman Report, it was found that only 2% graduates studying a PGCE to become primary school teachers had a degree in any of the STEM subjects. I find this a frightening thing. This is what led in the extreme case to my headmistress banning maths at my school. The key to education must start at primary, and if our primary school teachers are not able to inspire their students with mathematics, then we are in danger. We are in the danger of being locked into a cycle of poor mathematical performance for generations. I say fortunately, this is now changing, and I'll explain why in a minute. Another problem that we have with UK teaching of mathematics is poor perceptions of girls and maths. Now, girls obviously are half the population, and it's incredibly important that they feel fully engaged with mathematics teaching. And the media often portrays maths as being a, quotes, male-dominated subject. And I worry that that's a self-fulfilling prophecy, that if the media say it's male-dominated and just shows images of men, then girls will be put off doing mathematics, and therefore it'll remain male-dominated. So it's a somewhat self-fulfilling prophecy. It's also wrong. It's also wrong. Well, at least at university and at A-level level, it's wrong. It is male-dominated in the extent that there are more men than women doing it, but it's not male-dominated to the extent of saying it's overwhelmingly more men than women. And here's an important statistic which I think should be more widely known, that currently 42, this is the London Maths Society report, said that 42% of all maths undergraduates are female. Now, I don't think that's dominated. That's not actually far from 50-50. Here are the proportions of different subjects. This isn't a terribly clear slide, but there's mathematics on 42%. Interestingly, veterinary science is 82% female. Now, that implies to me that veterinary science is a far less balanced subject than maths is. And education is similarly less balanced. So I think it's unfair to say that maths is male-dominated, but there's still a long way to go before things are 50-50. For example, only 29% of maths lecturers are currently female, again, though that is improving. And I'm sad to say that only 6% of professors, so that really needs to change. 6% is not good at all. But one thing that is making a change, and things are changing very much for the better, is something called Athena Swan, which is a code of practice which universities have to sign up to and prove that they are doing things about, which is showing that they are improving the way that women and female undergraduates are dealt with in various different subjects, including mathematics. I'll go back to this. In 2011, then, this was the somewhat negative picture that we came to with the Vorderman Report, that we had a cycle of despair where people were underperforming in schools, they weren't going on to do post-16 education, university courses weren't getting enough students, primary school teachers were not getting enough maths education, and round we went. And that was a worrying thing that we put then, and we concluded our health of our economy depends on taking action now. And as I say, fortunately, things are now changing, and they are changing for the better. So what I want to do is give a few of my own ideas as to ways in which I think maths can be made more approachable and encourage more young people to do it. And then we'll have a look at some of the best practice and the way things are changing, and then that will allow us to look forward to the future. So some of my own ideas, these are things which I personally use in my own teaching, both at university and when I go into schools to work with young people there. And one is to show the magic of mathematics. So here's a bit of maths for us to do. The idea is you take any 3-digit number, doesn't matter what it is. I've written down 729, and then reverse it, you get 927. If you take the smaller of these from the larger, so that's 729 from 927, you get 198. If you reverse that, you get 891. And if you add those two together, you get 1089. And the point is you get 1089 every time you do it. And I challenge you to try this yourself and then try and work out why it works. Okay. So this is a magic trick. You can go into a school, you can do this, you can busk with this in the street. People do this as a way of showing that maths is a magical and a surprising subject. 1089 every time. This little trick led to a whole book. There it is, called 1089 and All That, by David Aitchison, who says in the introduction that when he first saw this trick, it, quotes, blew his socks off. And he then became a very eminent and extremely good mathematics professor who's written some wonderful books, including 1089 and All That, which is a bit of a takeoff of the 1066 and All That on history. Well worth reading. On the right, I won't do the trick with you, but my favourite mathematical magic trick, which I often do in schools, is called the orange kangaroo from Denmark trick. And you might want to go and look that up. If anyone wants to know about it, I'll tell you after the lecture. So I love teaching the magic of maths with young people by using magic. Why do I use magic? Mathematics is perceived, as we've shown already, to be a rather dry subject, very logical subject, and therefore a subject without excitement or surprise. And that is absolutely not what it is. Most mathematicians I know, in fact all the mathematicians I work with, find mathematics a very creative, a very surprising, a very mysterious subject. This trick here is mysterious, it's surprising. Why on earth is it 1089? And yet that's just the working out of a bit of mathematics. It's a mathematical theorem. And if we can demonstrate that surprise and excitement, then I think we've achieved a great deal and got people interested. My technique when I go into schools is I introduce them to magic like this. I then teach the maths behind it, and then I tell the young people to go off and design new tricks based on the magic they've learned. And I had a wonderful email from a young person that said that they'd done this, they designed a trick, they went home and they won £5 off their grandmother for doing it. So there we are. So teach maths using magic. Another thing I really think is important is to show the creative side of maths. Don't let people tell you that maths is not a creative subject. It's a very creative subject. But one way to demonstrate its creativity is to show links to other subjects which are perceived as being creative. So you can show links from maths to music. The scale that we use to play musical instruments with was designed by the mathematician Pythagoras, and we can make that link. Much of art has wonderful links to maths. This thing on the right is called the chased chicken design. It comes from sub-Saharan Africa, Angola, Mozambique, places like that. This was a creation of the African people there hundreds, if not thousands of years ago, showing beautiful, strong geometry. And I teach a whole workshop on this. And if you want to come to my Gresham lectures next year, I'm going to give a Gresham lecture on the links between maths and art. Well, I'll tell you a bit more about this. Maths and dance. Again, dance is perceived as a very creative thing. English dances in particular have a very strong link to mathematics. Folk dances can be described using the maths of symmetry. And very importantly, I think we should never... Maths is very often taught by opening up a book and saying, here's a quadratic equation, here's some coefficients, let's solve it. Doing that misses out the fact that that equation was discovered or created by people. There's a whole history as to how it was solved. The history is kind of interesting in its own right. And we should certainly link the teaching of maths much more with the people that have produced it and the history behind it. But above all, as I say, that's a wonderful pattern there. We can show the creative side of maths by encouraging young people to explore and discover new patterns. There is a dreadful film, which you should never watch, called Why I Detest Mathematics. French film, Pour je déteste les mathématiques, in which they interview various mathematicians who say, well, maths is creative, yes, but you've got to be a complete genius and have 10 degrees and have worked in the subject for 100 years before you can do anything creative with it. And that is completely wrong. Anyone can be creative with mathematics by exploring patterns and seeing what they can discover with them. And I encourage you to do that. A third thing I love doing is playing with maths. Maths is the ultimately playful subject. If you want to do high-energy physics, you've got to go to CERN and have billions of pounds worth of equipment. If you want to do creative mathematics, you need a piece of paper and a pencil. Okay, you don't even need the paper. When I was an Oxford student, we just used to write on the tables. And there we are. When I was a Cambridge student, which I should explain, after my terrible primary school upbringing, eventually I got to Cambridge, did my undergraduate degree there, and then did my PhD in Oxford. When I got to Cambridge, this thing had just come out, the Rubik's Cube, and all the undergraduates bought one, and we played with them. And we were learning in the first year the subject of group theory in mathematics, and this was by far the best way to learn group theory. And we became the envy of our friends because the maths that we were learning in our undergraduate degree allowed us to solve the cube, and therefore we could solve every other's cube, and suddenly we became cool. And that was kind of nice. Here's an example of a mathematical game where you have to fit pieces into a box in a certain way. It's what we call a sphere packing problem. And I take these to science festivals. If anyone is at a loose end this weekend, it's the Bath Science Festival, otherwise known as Bath Taps into Science. And you can come along for free. There's even free food, and we will give you things to play with. And this is the festival in action. This girl had just spent half an hour with us trying to solve that puzzle. Her mother said that we were doing a great child minding service. because she was fascinated, and everyone, look, they're all busy solving puzzles and having a great time. This is Benji the dog. That's my sadly late lamented dog, standing by a labyrinth, and I often take young people to labyrinths, let them loose in there, and say, try and find your way out, okay? And in order to find their way out, they have to do some mathematics, and if they get lost, we send in search parties and stuff like that. So maths is a very, very playful subject. To learn maths, you have to do maths. To do maths, you have to play, and we should bring that out more. And that should be 4, not 4.4. I strongly urge all teachers not to forget the career side of maths. Again, people very often get the wrong impression that mathematics is of limited use once you leave school, and the only careers for a mathematician are in accountancy and teaching. Now, accountancy is a great subject, great profession. Teaching is a great subject and great profession. But as I said at the beginning of this lecture, 70% of all jobs need some levels of maths, and many of these jobs are absolutely amazing. The biggest single employer of mathematicians in the world is Hollywood. And they employ many mathematicians to do all their special effects. 236 mathematicians were employed to make The Lord of the Rings. 236. That's a lot of mathematicians. And if you want to find out more, this is a website called the Maths Careers website, which is one of the websites maintained by the IMA. And if you go onto this, you'll get lots and lots of ideas as to maths careers at all sorts of levels, and lots of interviews with mathematicians doing that. Great resource. So there's our 4 things which I think can be done to make maths a bit more interesting and challenging and entertaining for those that do it. But I don't want to kind of give the idea that A, things are all doom and gloom, and B, the only solution is to do what I say. That would be a terribly wrong thing to do. I want to now talk a little bit about some of the great things that are going on in the UK at the moment, and then talk a bit about the role of technology in maths before looking into the future. So a lot of very good things have happened since the Vorderman Report in 2011, and I'm really quite optimistic about the way things are going in the future for teaching maths education. One is, despite my concerns that mathematicians give up maths, politicians give up maths too early, there have been some very good changes at the top, showing that the government and various learning societies are taking maths education much more seriously. One of the problems with universities is that the emphasis is, a lot of it's been on research, which is great, but maths education's been a bit forgotten, and that is changing. One of the examples of this is a body called ACME. That's the Advisory Committee for Maths Education, which has been set up by the Royal Society to act as a kind of umbrella for good ideas and good practice in maths education. And ACME is making a big difference. There's the Joint Maths Council. Mathematicians are finally talking to each other, and that gives us a way of doing it. And Adrian Smith has published 2 very important and influential reports which are guiding the way mathematics is going in the future, the teaching of that. So changes at the top are encouraging. Secondly, I told you that in 2011 we concluded one of the big problems with maths education in the UK was that people were giving up maths too early. We weren't the only people that said that. A number of different bodies said the same thing, and that has led to a big change in government policy. So here's someone you might recognise. I deliberately chose a photograph of him in 2011 because I suspect he'll be rather busy tonight. So Michael Gove was the then Minister for Education in 2011. In fact, he wrote the foreword of the Vorderman Report. And he said in July, we should set a new goal for the education system so that within a decade, the vast majority of pupils are studying maths right through to the age of 18. And I regard that as an incredibly important thing to say. Regardless of what you might think of Michael Gove, this is very, very positive. And immediately following that, ACME, the Royal Society body, was commissioned to produce a report about how this was going to be done. And the conclusion was that there should be 3 pathways for students studying maths after the age of 16. One pathway was the same as A-level, so students who really wanted to do maths at a high level, go on to university to do maths or engineering or physics, would continue to do A-level maths. The lower group was those who'd sort of struggled through GCSE, hadn't got a particularly good grade, but needed to be kept in touch with some level of maths so that they become numerate and could go on to all these jobs, and that was the 3rd level. But core maths was introduced for the middle range of students, which includes people like my daughter, for example, that are going on to have a career or do a university degree which will use some level of maths, but not the highest level of A-level. So my daughter was basically forced to drop maths at 16 because she wanted to go on to university to do social sciences, and the A-level choices that she essentially had to do meant that she couldn't do maths, which I thought was ridiculous. And then she goes to university and has fun, she has to learn statistics. She said, "I'm learning statistics, Dad." She's still doing social science. Core maths is a sort of middle level qualification going alongside A-level maths, which is aimed at students who are going to be using their maths in degree courses on their careers, but are not taking A-level. So here's some examples: social scientists, medical students, plumbers use a lot of maths, fashion, tourism, leisure, all these sort of areas, psychologists and so on, are now able to take this new A-level. Fantastic. And the emphasis of the A-level is much more based on problem solving and also on modelling and handling data and using all the digital technologies. So I'm very, very excited by this. And I'm proud to say that my university, University of Bath, now recognises this as a valid A-level for entry to these sort of subjects. Okay, so that's 2 good things. Here's a 3rd good thing. I think there's a lot of really good initiatives out there, educational initiatives. A lot of these are making full use of all the technology that we have available to us, particularly on the internet, showing a creative way to teaching maths, developing digital web-based resources, and new learning methods. It's terribly hard to list all of these because there's a lot of great initiatives out there. So I've just picked 3 here at random. So the Advanced Maths Support Programme. The A-level maths, when I did maths at school, when I did A-level maths at school, I did maths, further maths and physics. And further maths is what you did if you wanted to go on and do maths at a university. And then further maths got kind of sidelined a bit because it was expensive to teach and state schools found it hard to teach. And then a body called the Further Maths Support Network, which then became the Further Maths Support Programme and then became the Advanced Maths Support Programme, founded a sort of network of support to allow students, particularly in the state sector, to do further maths. And that's utterly transformed things. It means that many, many students are now doing further maths that never had a chance to before, and it's had the wonderfully positive effect on us at Bath that we've had to make our first-year courses harder because our students are better prepared. This is wonderful. The MEI is the kind of parent body of this, and the MEI does many other wonderful initiatives. One of the things I like about MEI is that they have introduced an exam paper in maths called a comprehension paper. So you get comprehension papers in English. This is a comprehension paper in maths where they give you some sort of mathematical paper to look at and ask you questions on it. I think this is a wonderful idea. There are, as I say, many organisations developing new curricula based on this, and an example of this is Cambridge Mathematics, based, as you might imagine, in Cambridge, that are doing these things. But there are many other great initiatives. Cornerstone is another one, and many more. So we're seeing great initiatives coming forward, and I'm very encouraged by that. Another place that maths is certainly improving in recent years is in my own area, higher education. So the Smith Report in 2004 Adrian Smith, recognised that young people were having different experiences at school from the ones they used to. And one of the manifestations of this is that students at university have been struggling a bit more than they used to in the past. I don't think it's a bad idea that we challenge students at university. That's, after all, what we're supposed to be doing. But there was a kind of philosophy of sink or swim, and that has very much changed. And since this, there's been a lot of very good initiatives at universities providing support for students. So there's a thing called the Sigma Network. The Higher Education Academy is very involved with this. My own university, we have a thing called MASH, which stands for Maths and Science Help. And the way MASH works is that if a student is struggling with their questions or just generally with the course, they can go into an environment which has got nice comfy chairs, lots of food, and lots of PhD students or friendly people around that can help them through. So this is a sort of support network. And 81% of all universities now have this sort of thing in place. And this is giving students, I hope, a much more supportive environment. Another thing I'm very excited about is the recent explosion in outreach activities in mathematics. Something very close to my heart. One of the reasons I wanted to be Gresham Professor of Geometry is because I believe passionately in outreach. And to a certain extent, this explosion started in 1978 at the Royal Institution. It took the Royal Institution 150 years, but in 1978 they had their first Christmas lectures on mathematics. And they wisely chose Christopher Zeeman, who at the time was head of maths at Warwick, to give the first of this series of lectures. Okay. And the TV people, the BBC, whoever it was, I think it was BBC, said, no, it can't be done. You cannot put maths onto TV. Everyone will turn off. And if you do put maths on TV, don't mention the word theorem and certainly don't mention the word proof. If you ever met Christopher Zeeman, you will realise this was pointless saying that to him at all. He delivered a fabulous set of lectures. This is his Gears from the Greeks lecture in the background. And everyone watched it, and it was a great success. I'm very, very proud to say that Christopher Zeeman was a former Gresham Professor of Geometry. He kind of started everything going, really. There was a huge positive response to his lectures from people all around the country, and the Royal Institution, in response to that, set up what's called the Maths Masterclass programme. So every Saturday, all around the country, there are workshops going on for young people, typically about 100 young people per workshop. These are all Year 9 students, about 13, 14-year-olds, are doing Royal Institution masterclasses somewhere in the country every Saturday. And if you know any Year 9 person that likes mathematics, point them in the direction of Royal Institution masterclass. Another thing that's been very good is Rob Easterway founded a thing called Maths Inspiration. Rob concluded that theatres were a great place to learn lots of things. So he takes theatre tours around the country, and typically about 1,000 young people go to each one of his theatre shows. And Rob has brought up a whole generation of kind of popularisers of maths by putting them through this theatre experience. Here is some other things. We're now seeing many more maths books. Fermat's Last Theorem by Simon Singh has sold huge numbers of copies. Many of the students that apply to my university put on their entrance form, I have read Fermat's Last Theorem by Simon Singh. I've told Simon this, he was very pleased. Here's Hannah Fry, who is the kind of current face of mathematics on TV. Last week, I was very pleased to go along to an occasion where Hannah was awarded the Zeeman Medal. So the Joint Maths Societies have set up a medal in honour of Zeeman for mathematical outreach, and Hannah has just won that, and she's doing a lot of great stuff on TV. If you want to actually see maths on YouTube, go on to Numberphile, which is an incredible resource on YouTube, And this is the equally incredible Matt Parker, who does a lot of these. He's called himself a stand-up mathematician, and he's well worth a watch. And there's lots of other stuff going on. So I'm very, very encouraged by this. And the fact that there's a growing body of maths communicators that are working in maths outreach, and there's going to be a conference coming up in Cambridge shortly called Talking Maths in Public, where this is all done. So lots of great initiatives. One of the things that's also very much driving the way maths is being taught in schools now is technology. And the UK is world leading this. One of the reasons world leading is due to Celia Hoyles, who I believe is in the audience somewhere. Thank you, she's just waving at me. Dame Celia Hoyles, who is possibly the world leader in mathematical use of technology in maths teaching. And so I've been fortunate in my own sort of career to have kind of grown up with this. So in 1970s, when I did O-level maths at school, I did O-level maths with this slide rule. And then towards the end of my O-level career, calculators came in, and there is the Hewlett-Packard calculator that I used for my A-level. That's the actual Hewlett. I still got it. So we see an introduction to calculators. There was lots of stuff in the press. Oh no, calculators will stop people doing mathematics because it can all be done by a calculator. And again, that's nonsense. It stops the calculation bit of mathematics, but the ideas it allows much more greater creativity. In the 1980s, we've seen a lot of digital technology coming in, which allow the subject to be illuminated. So this is GeoGebra, which is a package which allows you to do geometry and trigonometry and just play and be creative. And there's lots of these around. You can also have programmable robots, and these go back quite a long way. There's things called turtles, which were produced in, I think, 1970s, which you could program using the Logo programming language. Nowadays, Lego robotics, young people can program things and see them moving around. In the 1990s, we saw the introduction of new programming languages which allow high-level maths calculations. So I was trained as a Fortran programmer. I'm still a reasonably good Fortran programmer, but Fortran is not the way to train students to do mathematics. And now we have much more powerful tools like MATLAB and Python and so on Maple, which allow you to program a computer to do mathematics much more easily, and possibly even more importantly, to visualize the results. So this graphic here was done in MATLAB. That's about 4 lines of MATLAB to produce that graphic there. And that's led to a revolution in teaching maths at higher education. I couldn't conceive of teaching maths at university without using these tools here. And also when I work in industry and applied maths to the real world, these tools are very, very important. So that's various tools. We also have seen a change in the way that programming is taught. So programming is a little bit different from maths, but very, very closely related to it. My own day job is I program computers to do maths. That's what I do. So in the 1970s, I learnt programming at school. I did the SMP project, and they taught us programming. And then I went to the Hatfield Polytechnic and did it all. 1980s, BBC commissioned the BBC microcomputer, which allowed schools to program and do lots of stuff. And that was great. It meant that when I was teaching students back in the early 90s, they were coming to us knowing programming. But unfortunately, that changed. In the 2000s, computers got very sophisticated. People got very frightened of doing anything with them. And the packages on them became so good that programming sort of died out as a subject being taught, being replaced by IT. So you learn how to use Excel, but wouldn't learn how to program it. And Eric Schmidt of Google, who then was CEO, said in 2011, same time as the Vorderman Report, how flabbergasted he was that programming was no longer being taught in schools. But that's changed as well, and now very much the better. The Computers at School initiative, which was founded quite recently, has led a whole change so that computing programming is now taught in schools. The Python language, which is free, gives a very powerful language you can do maths in. And best of all, possibly, is you can now buy a computer for about £30 the Raspberry Pi, which will allow you to do all of this and is significantly more powerful than the mainframe I was programming when I went to the University at Cambridge. So this three, it's a nice, positive reinforcing circle. So I'm very, very excited about the future for maths being taught alongside technology. So just to say, I argue that computers are having the same effect on maths as the printing press did on English. They're not a substitute for mathematical thinking, but they do allow you to do independent creative work and complement maths and make it more fun. So I really see this as important. But I'll just finish on a somewhat downer note. I've told this vision I have for how maths will be taught in the future, but as I said at the beginning, how on earth will maths be taught in the future? And the problem with teaching maths is that to teach maths, you need teachers. The future of mathematics education is in the hands of teachers. They are absolutely vital. And teacher numbers are under pressure. So as pupil numbers are going up, they're forecast to rise by 90% by 2026. Core maths is fantastic, but we need people to teach it. And that's putting pressure on numbers, but only 50% of maths teachers to continue to teach in state schools 5 years after qualifying, according to a Nuffield report. So to teach maths in the future, we must recruit and keep more maths teachers. So the question is, how can we do this? It's so important. So there are various things that are possible. We can improve the way we do initial teacher training. So the National Centre for Excellence in Teaching Maths is leading a role in this, as are others. And we can improve CPD for teachers. We need to improve the way we recruit teachers, and there are various schemes out for doing this. So Teach First is a favourite of mine. A lot of my students go into Teach First. Teach First basically takes undergraduates and puts them straight into teaching as a sort of shock or sink or swim thing, and they love it. And the IMA, the Institute for Maths Applications, will provide bursaries for those who want to go into teaching. So this is something. And something else that I'm very involved with myself is trying to encourage more maths undergraduates to go into teaching. So Simon Singh, remember him, founded a thing called Undergraduate Ambassador Scheme, where young people, students at university, can go into schools and get credit for doing that. I run a slightly similar scheme at Bath, where my students help run science festivals and do masterclasses, and again get credit for it. But the whole point of this is to where our teachers are going to come from, largely from undergraduates at university. Let's encourage them to think of teaching as a great degree, a great career to go into, and try to persuade them that they don't have to go into just earning lots of money. So that brings me up to date. I think the future of maths teaching is probably rosy. I started on a sort of downbeat note. I hope I finished on a more positive one. I see a future where increasing use of technology in creative teaching will open windows in mathematical opportunity to a new generation who really will appreciate the relevance of maths in their lives. But this is only if we can get enough teachers. So the real future for maths education is in recruiting enough teachers. And just to finish, anyone come up with a solution to the problem? What was the answer?
2.5 times.
2.5 times, absolutely right. The answer is 3 times 2.5, which is 7.5 metres. So that's how big the shadow was cast. And just to keep you out of mischief as you go home, can you work out the maximum min number of Friday the 13th there can be in any regular calendar year? And on that thought, thank you very much.